Have you ever walked through a forest and felt like you were in the presence of something ancient and wise? Or watched a flock of birds move as one, a swirling coordinated dance in the sky? What if I told you that these aren't just random acts of nature, but signs of a vast, hidden intelligence, a complex network connecting all living things? Today, we're diving deep into the unseen truths of nature's intelligent systems, a world far more connected and sophisticated than we ever imagined. Let's start beneath our feet, in the silent, dark world of the forest floor. Here lies what some scientists call the wood wide web. It's a sprawling, intricate network of fungi, specifically their thread-like structures called mycelium. These threads connect the roots of individual trees, even trees of different species, across vast areas. This isn't just a passive connection. It's an active information and resource highway. Trees use this network to communicate. When one tree is attacked by pests, it can send out chemical alarm signals through the mycelial network to warn its neighbors. The other trees then ramp up their own chemical defenses, preparing for the incoming threat. It's a forest-wide security system. But it's not just about defense. This network is also a marketplace. Trees share resources like carbon, water, and nutrients. Larger, older trees, often called mother trees, act as central hubs. They nurture the smaller, younger saplings growing in their shade, sending them the nutrients they need to survive until they can reach the sunlight themselves. They can even recognize their own kin, their offspring, and preferentially send them more resources. Think about that for a second. A forest isn't just a collection of individual trees competing for survival. It's a cooperative, interconnected community, a superorganism where the whole is far greater than the sum of its parts. The health of the entire forest depends on this constant, silent communication and sharing. Now, let's look up to the sky. The mesmerizing ballet of a starling murmuration, where thousands of birds fly in perfect unison, is another stunning example of collective intelligence. How do they do it without a leader, without crashing into each other? It's not telepathy. The secret lies in a few simple rules. Each bird pays attention only to its closest 7 neighbors. It tries to match their speed and direction while maintaining a safe distance to avoid collisions. When one bird changes direction, its neighbors react almost instantly, and that change ripples through the entire flock like a wave, creating those beautiful, fluid patterns we see from the ground. This decentralized system allows the flock to react incredibly fast to threats, like a peregrine falcon. The collective confusion and constant movement make it nearly impossible for the predator to single out one bird. It's a masterful defense strategy born from simple, local interactions. This principle of collective intelligence, known as swarm intelligence, is everywhere. Think of an ant colony. There's no single ant in charge, no manager giving orders. Yet, as a whole, they achieve remarkable feats. They build complex nests with ventilation systems, farm fungi for food, and create living bridges with their own bodies to cross gaps. How? Through chemical signals called pheromones. When an ant finds a food source, it leaves a pheromone trail on its way back to the nest. The more ants that follow this trail, the stronger the scent becomes, attracting even more ants. This simple positive feedback loop allows the colony to efficiently exploit resources without any centralized planning. They are solving complex logistical problems as a collective, with each individual ant acting as a simple, autonomous agent. Let's go deeper into the ocean. Coral reefs are often called the rainforests of the sea, and for good reason. They are teeming with life, but the coral itself is a fascinating superorganism. A single coral structure is made up of thousands of tiny animals called polyps. Living within the tissues of these polyps are microscopic algae. This is a classic symbiotic relationship. The coral provides the algae with a protected environment and the compounds they need for photosynthesis. In return, the algae produce oxygen and supply the coral with the majority of its energy. This partnership is the foundation of the entire reef ecosystem. But there's more. The reef communicates. When water temperatures get too high, corals become stressed and expel their algae, a process known as coral bleaching. Recent research suggests that stressed corals can release chemical signals into the water, potentially warning nearby corals of the danger, giving them a chance to prepare their own defenses against the heat stress. It's another layer of communication in an environment we are only just beginning to understand. Even plants, which we often see as passive and static, have a secret social life. They don't just communicate underground through fungi. They also communicate through the air. When a plant is being eaten by a caterpillar, It doesn't just sit there. It releases specific volatile organic compounds into the air. These airborne chemicals are like a message in a bottle. Nearby plants can smell these compounds and start producing their own defensive toxins to make their leaves less palatable. But it gets even more amazing. These same chemical signals can also act as an SOS call to the cavalry. They can attract parasitic wasps, which are natural predators of the very caterpillars eating the plant. The wasp will then lay its eggs inside the caterpillar, effectively neutralizing the threat. The plant is essentially hiring a bodyguard through chemical warfare. From the forest floor to the ocean depths, nature is built on these intelligent, decentralized networks. What can we learn from them? Well, engineers and computer scientists are already doing it. The algorithms that guide delivery drones and optimize traffic flow in our cities are inspired by the foraging strategies of ants. The way we design resilient communication networks and even artificial intelligence is being influenced by the decentralized command structure of a bird flock or a fungal network. Nature has been running successful, large-scale experiments in networking and collective problem-solving for millions of years. It's the ultimate open-source code, and we're just starting to learn how to read it. When we look at nature through this lens, our perspective changes. A tree is no longer just a tree. It's a node in a living network. A flock of birds is not just a group. It's a collective mind in motion. This understanding fosters a deeper sense of connection and respect for the natural world. It reminds us that we are part of this intricate web, not separate from it. The challenges our planet faces, from climate change to biodiversity loss, are disruptions to these vital networks. By understanding how these systems work, how they maintain balance and resilience, we can learn how to better protect them and perhaps even how to heal the damage we've done. The next time you're outside, take a moment to look closer. Listen to the silence between the trees, watch the coordinated flight of insects, and remember the invisible world of connection that pulses with a life and intelligence all its own. Nature is speaking, communicating, and collaborating all around us. We just need to learn its language. Thanks for joining me on this journey into nature's hidden intelligence. If you found this as fascinating as I do, hit that like button and subscribe for more deep dives into the wonders of our world. Let me know in the comments which natural network fascinates you the most. Until next time, stay curious,